Hey folks, just wanted to take a minute to describe how I've got my shore power, transfer switch, and portable generators all installed on this 2020 Grand Design Reflection 311 BHS. So we do have two Onan portable generators that I run in parallel, and they hook up outside via shore power with a 50 amp connection. So I'll take a minute here and just show you how it's hooked up. Right now we are running on battery power only. The shore power is disconnected. So I installed this last season and installed a WFCO 50 amp transfer switch. It's a WF-T57-R. It's installed in behind this AC panel, distribution panel. I knocked out this panel here to make an easier install. So as you can see, the shore power comes in from outside, goes into the transfer switch right there, and comes out right there and plugs into the back of the AC panel. So basically that big cord that gave me plenty of room, just cut it and wire it in. Now I'll talk a little bit about how it is wired in. I'm trying to give you a close-up view here. As you can see, the shore power is hooked into the generator side of things. It is a generator transfer switch. And the reason it's hooked into the generator side is the generator is the primary on this transfer switch. And what that means is it takes priority over everything else. So we don't want our inverter taking priority. If the inverter is on, we don't want it to start powering things when both are available. We want the shore power or the generator to be priority. In my case, the generator comes from the shore power. So it is a 30-second delay. So when you plug in the shore power, it takes 30 seconds for it to connect, which is not a bad thing because that 30 seconds actually allows our generators just a little bit to warm up and stabilize and come online. Take just a minute here to describe how the inverter's wired in. So the inverter is only wired on one leg of this 50 amp connection, and I'll talk about that here in just a moment. But as you can see, the shore power, both legs are connected, they're red and white wires, but the inverter is only one leg. This other leg right there is not connected. So when it's connected, that inverter is only powering these circuit breakers right here. These ones are not powered, so it's only powering one of these legs, not this leg. And the main reason for that is if you look at how we've got this connected, it's only going to power these circuit breakers, which is our GFCI plugs, microwave. I moved the receptacle over from this side over to this side, so all the receptacles have power. And then also our fireplace and front bedroom air conditioner, but we won't run those off the inverter. But the main deal here is this converter is not getting power from the inverter, so it's not going to feed itself and cause an inefficient loop. So when we plug shore power in, I'll show you how that works. Start a 30-second timer. When that comes on, or the generators come on and stabilize, you'll hear it click down there. And the first thing that comes on is the microwave. So it's kind of the only negative about that is you do have to wait 30 seconds, but like I said, it works out good to let things stabilize. So there we are on shore power. Now when I turn my inverter on, you'll hear it beep, turn on, but the inverter is not powering it. If we were to unplug the shore power, it'll instantly put it on inverter power. So if the generator shut down, boom, instantly it's on the inverter power. Now we do notice there's a little interruption in service, like if you're watching the TV. There you go, there you see the inverter is powering, it's on, and microwave still has AC power. But we will notice the TV will sometimes cut out because it just doesn't transfer that fast. So anyways, if you have any questions, let me know. Thanks for watching.